Good day, class. Our topic for today is all about counting techniques. I know you are all excited to discuss this. First, let me show you the mission and vision of our school. Here's our objectives. After completing this topic, students should be able to understand the concept of probability and its importance in inferential statistics. Also, students should be able to appreciate the counting techniques and its principles. Lastly, to be able to recognize or distinguish permutation rules and combinatorial rules. Let us first study what is the importance of probability in inferential statistics. Well, based on our research, here are some importance and role of probability in inferential statistics. First, probability is used to predict the types of samples that are likely to be obtained from a population. Second, probability establishes a connection between samples and populations. Lastly, inferential statistics rely on this connection when they use sample data as the basis for making conclusions about populations.
Let us now discuss some basic concept of probability. Probability is a mathematical tool used to study randomness. It deals with the chance of an event occurring. For example, the P of A, or this can be read as the probability of event A. To calculate the probability of an event occurring, it is equal to the number of favored outcomes or outcomes that lead to event A occurring divided by the total possible number of outcomes. Before we illustrate how to analyze the probability, we have to understand first the sample space. Basically, it is defined as the set of all possible outcomes that can occur. For example, what are the possible outcomes in tossing one coin? We can get only two possible outcomes, the head or tails. So, the sample space for this situation is either head or tails. Now, let's make it two coins. What are the possible outcomes, or what is the sample space for tossing two coins? We need to use the tree diagram to help us to get the answer. When tossing first coin, we have two possibilities, the head or tails. Now, let's say we get head in the first flip. In the second flip, we get another two possibilities, the head or the tails. Similarly, if we get tails on the first flip, we can also get two possibilities in the second flip. We can also get head or tails. So, we can have four possibilities outcomes. The first outcomes, which is head and head, so we can write as H. The second outcomes are the heads and the tails, can be write as H and T. The third outcomes are tails, then heads. Then the fourth outcomes will be tails and tails, or can be write as T. Therefore, this is the sample space of two coins. So, let us now make it three coins. What will be the possible outcomes, or what is the sample space for tossing three coins? Let us again the tree diagram to know the sample space. For this On the first flip, we get head and tails. If we get heads, we can also get another head and tails. And if we get tails, we can also get another head and tails. Since we are using 3 coins here, we have to repeat this one more time. We have also H and T, and then repeat the process. Here's the first possibilities. We have 3 heads and we write as H, H, H. The second possibilities was head, head, tail, or we can write as H, H, T. The third possibilities was head, tail, head, or we can write as H, T, H. And the fourth possibility is head, tails, tails, so we can write by H, 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 T, T. And then repeat in this process. We see that the next process will be T, H, H, and then T, H, T, then T, T, H, and last one is T, T, T. Then, the number of possible outcomes will be 2 raised to the third power, which is 2 times 2 times 2 times 2, because we are using 3 coins. Therefore, we have 8 possible outcomes, and this is the sample space for flipping 3 coins.
Now, the probability of an event occurring is always between 0 and 1. If the probability is 0, it means that this event will never happen. Now, if the probability is equal to 1, that means the event will always happen and it has also 100% chance of occurring if the probability of the event occurring is 0.4 out of 10. So, this means that there is 4% of chance occurring. Here is our example situation. We have 10 unexpected visitors arrive yesterday from Malaking Pulo. I randomly asked them if they want to take any dose vaccine, and 0.4 said yes. Well, I can say that the probability of person who will take the vaccine is only 4%. If and only if I make a random survey to 100 people, it means that 40 individuals will take the vaccine. Same as when we get random survey on 1,000 people, there are approximately 400 people will take the vaccine, and that is what probability tell us.
Here are some situational problems that are related to our first 3 examples earlier. Okay, if 2 coins are flipped, what is the probability of getting at least 1 tail? So, let us start by flipping 2 coins. We get the head-head, head-tail, tail-head, and tail-tail. Remember that event A is asking for at least 1 tail. So, second and third has 1, and fourth has 2t. Then, their due sample of space is HT, TH, and TT. Now, let us calculate the probability in order for the event to occur. We have 3 favor outcomes and the total outcomes are 4. Therefore, we can say that the probability of getting at least 1 tail is 3/4. 3 divided by 4 is equal to 75, which means that there is 75% of getting at least 1 tail. Let's have the second event. If 3 coins are flipped, what is the probability of getting at least 2 heads? Like what we have mentioned earlier, we have 8 possible outcomes or event. We have HHH, HHT, HTH, HTT, THH, THT, TTH, and TTT. So the event B is asking for at least 2 heads. We have HHH, HHT, HTH, and THH. As you can see, we have 4 favor outcomes out of 8. Therefore, the probability of getting at least 2 heads is 4 over 8, which is equals to 1/2, and that is equivalent to 0.5, or 50% chance of getting at least 2 heads. Let us now move on to event C, wherein we are about to get the probability of exact one tail. We have here HHT, HTH, and THH. So, we have 3 favor outcomes out of 8. We write as the probability of 3 divided by 8, which is equivalent to 0.375, and is actually 37.5% chance of getting exactly one tail. And those are the probability of an event occurring. Since we have known now the concept of probability, now let's move on to our topic, which is counting techniques. Why do we have to study these counting techniques? Basically, counting techniques are very basis of being able to find the different probabilities of events in any kind of situation. This is not counting one by one, but this is collectively counting all possible ways of a given instance. Counting all 4-digit plate number whose digits are different among another one. In fundamental principles of counting, or also known as multiple rule, if it states that if there are P ways to do one thing and Q ways to do another thing, then there are P times Q ways to do both things. Just simply multiply the numbers of possibilities for each part of an event to obtain the total. Example, how many complete dinners can be created from a menu? With 5 appetizer, 8 entries, and 4 desserts. If a complete dinner consists of 1 appetizer, 1 entries, and 1 dessert, we have simply multiplied 5 times 8 times 4, which is equals to 160.
Here is our second example. I have 4 Korean skirts, 6 sleeveless tops, and 3 different color of plain shirts. How many clothing appearances can I create? So we just have simply multiplied 4 times 6 times 3, which is equal to 72. Take note that it is used to combine individual characteristics to form one complete piece. It is very useful in computing probabilities involving sequences of events. Let us now talk about the addition principle, or also called as the sum rule. In this principle, we add the number of possibilities for different ways to complete an event to obtain a total. So here's our example. How many ways can post-secondary students be selected from a group of 120 undergraduate students and 56 graduate students? The solution for this is just simply add the 2, the 120 and 56, which is equivalent to 176. And that's it. We have 176 ways. Remember that addition principle is generally indicated by the word or, plus, sum, total, and together. Addition principle is used to put complete pieces of together in complex situations. It is useful in counting possibilities involving choices among unique options. Let us now move on to permutation. Permutation can be defined as an arrangement of objects in a definite object. Number 1. Permutation of different things. The number of permutation of n different things taken are at a time. It is equals to n times the quantity of n minus 1 times the quantity of n minus 2 ellipsis times n times the quantity of n minus r plus 1. Here is the formula for getting the permutations of no repetition occurs. The permutations of n and r is equals to the n factorial divided by the quantity of n minus r factorial. Like for example, in how many ways can 4 students be seated in a room where there are 9 seats or chairs? Since there are no repetition occurs, we are going to use the formula. The permutation of 9 and 4 is equals to the 9 factorial divided by the quantity of 9 minus 4 factorial. So, the factorial of 9 is equals to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the quantity of 9 minus 4 factorial. So, that is equivalent to 5 factorial. 5 factorial is equals to 5 times 4 times 3 times 2 times 1. We just have to cancel or eliminate 5, 4, 3, 2, 1 on the upper part rather. Then we have now 9 times 8 times 7. Oh, may pahabol. Times 6 pa pala. So, 9 times 8 times 7 times 6 is equals to 3024. Therefore, we have 3024 ways. If the value of n is equals to r, use this formula. P is equals to n factorial over the quantity of n minus n factorial. So, it is equals to n factorial over 0 factorial, which is equivalent to n factorial. Take note that 0 factorial is equivalent to 1. Now, let's have an example. 4 different colored flags can be hung in a row to make a coded signal. Here's the question. How many signals can be made if a signal consists of the display of one or more flags? On one flag, the permutation of 4 objects taken only one at a time. It is equals to 4 factorial over the quantity of 4 minus 1 factorial. It is equals to 4. Because 4 minus 1 is equals to 3. We come up into 4 factorial over 3 factorial. On 2 flags, the permutation of 4 objects taken twice at a time. So, 4 factorial over or divided by the quantity of 4 minus 2 factorial, it is equals to 12. to those who don't know how to compute the factorial of 4 is 4 times 3 times 2 times 1. So, let's move on 3 flags. The permutation of 4 objects taken 3 at a time, it is equals to 4 factorial over the quantity of 4 minus 3 factorial. So, it is equivalent to 24. On 4 flags, the permutation of 4 objects taken 4 at a time. So, we can use the formula that I've already discussed earlier. That n factorial over 0 factorial, because our value of r is equals to n. So, we have 4 factorial over the quantity of 4 minus 4 factorial is equals to 4 factorial, which is equivalent to 24. So, the total signals is 64 because 4 plus 12 plus 24 and plus 24. Let us consider permutation with repeated elements, or the permutation of n things, not all different. The permutation of n things taken n at a time, in which k sub 1 are alike or the same, k sub 2 are another alike, and so on. It is expressed as p is equals to n factorial over k sub 1 factorial times k sub 2 factorial. We use the variable k to represent alike elements. In the word mom, 2 m are alike. 1 m cannot be distinguished from another m. So, there are 2 permutations of the m's among them. But, the word mom has only 3 distinguishable permutation taken 3 at a time. They are MOM, MMO, and OMM. So here's our example. Find the number of permutation which can be formed from the letter or word Philippines, or PHILIPINES. Our solution for this are, we have 11 letters, we have 3 P's and 3 I's. Therefore, P is our formula for this is P is equals to n factorial over k sub 1 factorial times k sub 2 factorial. It is equals to 11 factorial because it is 11 letters over 3 factorial times 3 factorial because we have 3p and 3i. So, the factorial of 11 is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over 3 factorial times 3 factorial, which is equivalent to 3 times 2 times 1 times 3 times 2 times 1. So, the factorial of 11 is equals to 39,916,800 divided by 36. It is equivalent to 1,108,800. So we have another example. What is the number of permutation of the letters in the word banana. So we have here 6 letters in the word banana with 3A, 2P, and 1B. So we're going to use the formula P is equals to n factorial over K sub 1 factorial times K sub 2 factorial, which is equivalent to 6 factorial divided by 3 factorial times 2 factorial. So 6 factorial is equals to 6 times 5 times 4 times 3 times 2 times 1. Then, on the denominator, the 3 factorial, 3 times 2 times 1 times 2 times 1, which is equivalent to 60. Also, we have cyclical permutations. Cyclical permutations of n, different things taken n at a time, is equals to the quantity of n minus 1 factorial. We have to first subtract 1 to the n, then perform the factorial method. We have an example here. In how many ways can 6 people be seated in a round table with 6 seats? So, our answer for this is we have to use the formula given. P is equals to the quantity of n minus 1 factorial, which is equivalent to the quantity of 6 minus 1 factorial. So, it is equivalent to 5 factorial. 5 factorial is equals to 5 times 4 times 3 times 2 times 1, which is equals to 120. Therefore, we have 120 ways. We have another example here. 4 couples are about to eat at a round table with the men and women alternating. If the hostess reserves a place for herself, in how many ways can she assign seats to the others? So, our solution for this is P is equals to the quantity of 4 minus 1 factorial times 4 factorial. So, 4 minus 1 is equals to 3. We have 3 factorial is equals to 6 times 4 factorial. So, we have 144 ways. Let us now move on to combination, or also called as combinatorial rule. So, here's the definition of combination. A set of things is a group of all or of any part of the things in this group, or it is a collection of objects in no particular order. We have combination of n different things taken r at a time. It is equivalent to n factorial over n minus r factorial times r factorial. And that is the formula for the combination. We have here the sample problem. How many combination can be made out of the letters A, B, C, D, and E, taken 2 at a time? So, the combination of 5 different letters taken 2 at a time is equals to 5 factorial, because we have 5 letters here, divided by the quantity of 5 minus 2 factorial times 2 factorial. Take note that we have to first subtract the numbers inside the parentheses. So, 5 factorial is equals to 120. Then, we divide by 3 factorial times 2 factorial. 3 factorial is equals to 6 times 2. Then, 120 divided by 12 is equals to 10. So, we have 10 combinations. Let's have another example. Compute the number of 8-letter combination of all letters in the alphabet. Our solution for this is the combination of 26 different letters taken 8 at a time. So, 26 factorial over the quantity of 26 minus 8 factorial times 8 factorial, which is equivalent to 1,562,275. Here is our last example. The Lotto, or small town lottery, uses numbers 1 to 42. A winning number consists of 6 different numbers or digits in any order. So, here is the question. What are your chances of winning in it? So, we have to compute and use the formula C. The combination of N and R is equals to N factorial divided by the quantity of N minus R factorial times R factorial. So, it is equals to 42 factorial divided by the quantity of 42 minus 6 factorial times 6 factorial. So, our answer is 1 over 5,245,786 chances of winning.
Sample problem number 1. How many arrangement can be done for the letters in the name Pranpriya Manobal? In this case, we consider permutations with repeated elements. The number of permutations of an element taken n at a time with n sub 1 element alike, n sub 2 of another kind alike, and so on is expressed as n sub 1 all over n sub 1 factorial, n sub 2 factorial, and so on. It should also be noted that n sub 1 plus n sub 2 plus n sub 3 plus plus n sub z is equals to n. So, in the word Pranpriya Manobal, take note that P appears 2 times, R appears 2 times, A appears 4 times, N appears 2 times, and I, Y, M, O, B, and L appears only one each of at a time. So, in the word Pranpriya Manobal, we have 16 letters. Let's check it. N sub 1 plus N sub 2 plus N sub 3 plus N sub 4 plus N sub 5 plus N sub 6 plus plus N sub 16 is equals to 2 plus 2 plus 4 plus 2 plus 1 plus 1 plus 1. So, it equals to 16. Then, the permutations of Pranpriya Manobal is 16 factorial all over 2 factorials times 2 factorials times 4 factorials times 2 factorial. First, we should get the factorial of 16, which is 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. All over 2 times 1 times 2 times 1 times 4 factorial times 2 times 1. So, we can cancel out the 4 factorial. So, then, we multiply 2 times 1 times 2 times 1 times 2 times 1 is equals to 8. Then, cancel out 8. Then, multiply the remaining numbers or elements, which is 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 7 times 6 times 5. So, we can get the answers of 100,972,864,000. So, we have 108,972,864,000 arrangement can be done in the letter of Pranpriya Manobal. Sample problem number 2. Blackpink was originally planned to consist 9 members but ended up in 4 on June 29, 2016. If there was 9 potential members for the group at the time, how many different teams could be formed? For this problem, we can use the formula of permutations of n object taken R at a time, which is P subscripts of n and R is equal to the n factorial all over the quantity of n minus R factorial. So, our n is equals to 9 and our R is equals to 4. So, we can substitute the given to the formula. Then, the P subscripts of 9 and 4 is equals to the 9 factorial over the quantity of 9 minus 4 factorial. So, we can just copy the 9 factorial, then 9 minus 4 is equals to 5 factorial. So, we can get the 9 factorial all over 5 factorial. Then, we can get the factorial of 9. So, it will be 9 times 8 times 7 times 6 times 5 factorial. Since our denominator is 5 factorial, we can cancel out the 5 factorial. So, we can multiply the remaining numbers. The 9 times 8 times 7 times 6. So, we can get the answers of 3,024. So, there are 3,024 different teams can be formed.